In this lesson today, which is lesson 2 of Unit 6, we're going to be going over isosceles triangles. Let's go ahead and get started. Just a reminder, the definition of an isosceles triangle is a triangle with two equal side lengths. So to label, see our figure over on the right, the two congruent sides are often called the legs of the triangle. And then that third side is often called the base of the triangle. So more often than not, you'll see it represented this way, where the base is at the bottom and that the two legs that are again the congruent sides are shown above it. And then the vertex angle we often refer to as that angle that is formed by the two legs. So if we look up here, I'm gonna grab my laser pointer here, the two legs meet at that vertex angle up top. And then the base angles are these two angles here that are formed along the base. So the base is connected to both of those two angles. And the isosceles triangle's base angles theorem, quite the long name, is that the base angles of an isosceles triangle are congruent. So that's what these two orange arcs mean here. And this is true for any isosceles triangle. So it doesn't matter how open that vertex angle is or how closed that vertex angle is, the two base angles will be congruent in an isosceles triangle. We can prove that this is true. And so if we look here, we have a triangle XYZ, and it is given that it is isosceles because XY here is congruent to XZ. And we're going to say that this line segment here, which is marked with this dashed line, XB, is going to bisect angle YXZ. And our goal is to prove that angle Y is congruent to angle Z, that our two base angles are the same. So we can start off using our given statement as usual. So refill our given statement in here, and the reason is, well, it was given to us in this context. The next thing is, well, we're told that XB bisects this angle XYZ, so again, or sorry, YXZ. YXZ is that top angle, or to use our new term, that's our vertex angle. And if this is the angle bisector, that means these two angles will be congruent to one another, because that's what an angle bisector does. It splits into two congruent angles. And then the next thing we can say is, well, XB is being used by both triangles, so it's congruent to itself, and that's our reflexive property. If you had me for first semester, we also called this our no-duh property. Mr. Swatala, feel free to steal that one if you want. And then our fourth item here is now we have this side, angle 1, and this side. So we have side, angle, side, and then the corresponding side, angle, side for our second triangle here, a second smaller triangle on the right. So that means these two smaller inside triangles, YXB and ZXB, are congruent. And then finally, using some of our skills we learned last quarter, or last semester rather, we can say, well, angle Y and angle Z must be congruent by corresponding parts of congruent triangles being congruent. So again, we started with this triangle that was a isosceles triangle, and we said, well, if we split that vertex angle down the middle, then we can show that these two angles must be equal to one another because they create these two congruent smaller triangles. Next, we can look at the converse of the base angles theorem. Again, the converse just means that we are taking our logic, and if you had me last quarter, we talked about applying our Uno reverse card. So we're flipping the order of the logic. We're taking what was the statement before and making it our result. And then our old result now becomes our statement. So it says if we know that the base angles are congruent, which would be angles A and B in this case, then it must be the case that these opposite sides opposite the angles, are congruent, which means that the legs are congruent. So if I ever have a triangle with exactly two congruent angles inside, that means that I also have an isosceles triangle. Here we can look at some applications of either the theorem or the converse. So the first part here, part A on number 5 in your notes, is we're going to take angle WVS, which is WVS, this angle right here, and show that it's congruent to angle S, knowing that WV and WS are congruent based on that figure there. And we can use what we just talked about. Because WV and WS are congruent, these marks here, then we know that triangle VWS is in fact an isosceles triangle, which means that by the base angles theorem, the angles must be congruent. Here on part B, I'm looking at TR is congruent to TS, and so we're looking at on this larger figure over here, we can use this, but we're going to start off with this angle here. So we have TR and TS, and we could use maybe this subset figure here. And we know that angle R and S are the same, so this bigger triangle must be isosceles. We can get that from this smaller triangle here, V and R being the same. And then V and S must be the same because this triangle is isosceles. So again, R is congruent to S over here. So VWS now must be a congruent, or sorry, must be an isosceles triangle. Our goal is to say that TR is congruent to TS. So now that we have that angle S is congruent, now we have these two base angles being congruent. So we can say now that TR and TS, these two legs up here, must be congruent. This would be by the converse of the isosceles triangle base angles theorem. Moving on to a few more fun facts within our realm of triangle properties. We can extend this idea onto equilateral triangles. And so if we have a triangle that's equilateral, then it's also going to be equiangular. I know I say equilateral probably different than you do. You probably say equilateral, which is fine. I won't judge you if you don't judge me. And then if a triangle is equiangular, then it is also equilateral. So we have the same relationship here where if I have all three sides the same, I must also have all three angles the same, and vice versa. So here we have our last few problems. I want you to pause the video here and see if you can figure these out on your own, and then I will go through each of the solutions. All right, I'm going to start off with part A here. So our task is to find the value of the variables. The only variable that I see here is this variable t. And a couple things that I noticed, let's zoom in so we can see this a little bit better here, is while I have these two equilateral triangles, I'll have an equilateral triangle based on these marks here, here, and here. I also noticed that this one is also an equilateral triangle of the same size, so those are also all equal length sides. And what that means is that if I have an equilateral triangle, I also have an equiangular triangle. So each of these angles is the same. And so if we're trying to figure out what is the measure of each of these blue angles, well, I know two things. I know the interior angle sum should add up to 180, and I know that each of them is the same. So if I give these each, let's say the value of x, then I would say 3x is equal to 180 degrees, which means that x is equal to 60. So let's go through and let's replace each of these x's with 60. And then these blue angles again are the exact same, so these would also be 60. And then the last thing that I can use here is I have this thing here, this box, which represents a 90-degree angle there. And finally, I guess there's one more thing that I can use to my advantage, and that is the fact that I have a circle here. So if I was to draw this as a circle, I know that a circle has a degree sum of 360 degrees. So if I was to use this to my advantage, I would say that 90, grab my red here, 90 plus my two 60s, 60 plus 60, plus my unknown value, which is t, these have to add up to that 360 degrees. So now I can use this and I can say, okay, 60 and 60 is 120, 120 plus 90 is 210 on the left. Still have my 360 on the right. And then finally, if I subtract the 210, I will get a total of t is equal to 150. And that takes care of part A. Let's go ahead and look at part B. All right, noticing a few things right away. I'm just going to go in and mark some of those things. I see that I have equilateral triangle here as well as here. And based on our work from part A, that means that each of these angles definitely going to be 60 degrees for each of the vertices. So that means that x here is 60 degrees. I've already solved for x. Just using the work that I've already done. All right, and then, so this angle right there is that 60 degrees. It's written in black. And if that's 60 degrees, well, then I can find the angle of y for a couple reasons. Well, if this is 90, then this would also have a 90-degree angle there. So I have a triangle that has angles 90 and 60. If I have a right triangle using our skills that we learned in this lesson, that means that my two separate angles, y here and this 60 degrees, must be complementary. So let's use purple here for y. So this angle, y, plus the 60 degrees that I have in the bottom left corner of that triangle, these would be equal to 90. They're complementary. So if I subtract 60 from both sides, then I get that y is equal to 30 degrees. Or I should say that y is equal to 30. The degree symbol is separate from the variable. Y is equal to 30. So we have y equals 30. I'm just going to grab this, excuse me, move it up here. I have this straight line here, which means that this angle must be 180 degrees. So I can say that z plus my 60 degrees must be equal to 180, which means that if I subtract the 60 from both sides, just leave that in red here, then I get z is equal to 120. So there are my three variables. Let's take a look at part C. All right, this time we have kind of the opposite of what we had before, where we don't know that all the side lengths are the same right away, but we know all the angles are the same in this triangle. So we have this angle congruent to this angle, congruent to this angle. And what that tells me is I can use the fact that this is now equilateral triangle to say that those three side lengths are the same. So if those are the same, then I can say with confidence that y is equal to 4. So that takes care of the variable of y. And then I have this bottom triangle down here, which we'll mark here in green, has two arcs. I mean, it's not the exact same angle as the angle up in triangle K and L, but they are equal to each other, which means that this is an isosceles triangle. And you'll notice that this is one of those legs of the isosceles triangle, so that means that this would be congruent to that leg over on the left. And we said earlier that this was the same, so this was 4, and this is also 4. So that means that I can set this up as x plus 1 is equal to 4. And if I subtract 1 from both sides, I get that x is equal to 3.
Okay, so that should wrap things up. Again, if you are coming over from Mr. Swatala's class, check in with him in terms of what your assignments are. For those of you that are in my class, everything should be posted to Google Classroom. So if you're accessing this video, then you're probably already in the assignment post itself. But hopefully everything made sense. If it doesn't, feel free to reach out to your respective teacher, either myself or Mr. Swatala. Ask any questions. Please don't be shy about those. I know he and I both appreciate those questions. They help us move the conversation along. So yeah, thanks for watching the video and sticking around, and I will catch you in the next one.